Hello everyone, I am Sharmishta Mitra and I have completed my internship from Emertxe Information Technology. The project was based on IoT based home automation system and I am currently pursuing my fourth year from Dr. D.Y. Patil Institute of Engineering Management and Research, Akurdi, Pune. I and my partner Rishikesh Kumar have built this project. So what was the project? So introduction of the project is a domestic automation system usually that connects control devices to the central hub or the gateway. So we have created a water tank, and we have automated the water tank. If the water tank is filled fully with the water, we will get the notification, and if we are emptying the water tank, then we will get the notification. Also, we have automated the garden lights. So if we are switching on the garden lights, we will get the notification that the garden lights are turned on, and if the garden lights are turned off, we will get the notification that it is turned off. So in this internship, we have learned C programming, different fields. We have learned three levels of programming, that is low level programming, middle level programming, and high level programming. We have learned the keywords and categories of the code. We have done the data representation, that is number systems and data representation in bit, byte, and word. We have also done the data types basics, that is integral and floating point, and also we have done the modifiers and qualifiers. We have also done C++ programming during the tenure of our internship. So we have done four basic pillars of OOP, that is object oriented programming: abstraction, encapsulation, inheritance, and polymorphism. We have done virtual functions and classes, template functions and classes, and standard template libraries. So giving you a gist of what is our project based on, it is based on IoT, that is Internet of Things. Internet of Things is network of physical objects or people called things. So the goal of IoT is to extend internet connectivity from a standard device like computer, mobile, tablet, or relative dumb devices like toaster. So what were the project requirements? So we have the requirements of the software part, that is Arduino IDE to code. Basically, it was a sketch. We used PICSim Lab for simulation of the project. We have used the Blynk IOT app on the mobile and mirrored it. We have also used the virtual serial port driver to configure the ports of the serial remote tank, that is the tank which will store the water. The Arduino IDE. The Arduino IDE, that is, it contains a text editor for writing code, a message area, a text console, and a toolbar with buttons for common functions as a serial of menus. So we have required the PICSim Lab. So PICSim Lab is a real-time emulator of development boards. PICSim Lab has integration with MPLab X IDE. So for the Arduino part, we have used this PICSim Lab for simulating it with the help of hex file. Blynk IoT app. So Blynk IoT app is a full suite of software required to prototype, deploy, and remotely manage the connected electronic devices at any scale. So it is used for personal IoT projects to million of commercial connected projects too. The embedded system. So as everyone knows, the embedded system is a combination of a computer hardware and a software designed for a specific function. The systems can be programmable or have a fixed functionality, and the industrial machines, consumer electronics, agricultural, and everything can be dependent on this, and we can do a simple coding and do a embedded system project. So light emitting diode. What is light emitting diode? It is the simplest device used in most of the embedded application as a feedback. So it works as a diode, but it is low energy consumption and it is of longer life. So we can do applications such as home lighting, remote control surveillance, and display many more things. What is CLCD? So CLCD is basically it is used to display the characteristics, that is ASCII characteristics. So it has two modes, that is 8-bit mode and 4-bit mode. LDR, light dependent resistor. So LDR is light dependent resistor, as the name state, is a special type of resistor that works on the photoconductivity principle, means that resistance changes according to the intensity of light. Its resistance decreases with the increase of the intensity of the light. So in the project we have done the LDR part during the automation of garden lights. This is the serial tank. So serial tank is basically connected with the Arduino, and due to the project we are considering the automation of serial tank, that is when it is filled we will get the notification that it is filled, and when it is emptied we will get the notification that it is emptied. So we will see further project implementation. So this is our project screenshots. So we will now see the actual project implementation. So this is the code that we have built on Sketch, that is Arduino IDE for home automation project. We have included all the required headers here. So as you can see, we have added the headers and the libraries that are required here at the starting of the main file. So before the main file we have added the libraries. Here we have also added the authentication code that is used to connect the Blynk IoT app with the system. As you can see, here we have added the authentication token, and here we have selected Uno board here. So as you can see, we have selected the Uno board, and we have to convert this code to hex file and upload it into PICSim Lab so that PICSim Lab can have smooth working. This is our whole code. Coming towards the PICSim Lab. So this is the PICSim Lab board, and we have chosen our Arduino board here. And in the sparse part module, we have connected CLCD dashboard. Here we can see the temperature and volume. We can also monitor whether inlet valve is on or off. We have LED light here. So as you can see, we have LED light. When the LDR sensor will sense the light, Arduino board can't be connected directly to the internet. So we have connected here the extra additional peripheral, that is Ethernet shield. So Ethernet shield, this is the Ethernet shield. So we will be connecting and sensing the temperature through the above. As you can see, the fan will be there. This is the temperature sensor. So now I am mirroring my mobile to show Blynk IoT application. We have created two tabs, that is tab 1 and tab 2. There are two buttons in tab 1, that is one is of heater and one is of cooler, and the gauge will show the temperature, sense the temperature, and will show same as in CLCD. So notification can also be viewed here in the tab. So in the tab 2 we have created two buttons, that is inlet valve and outlet valve. So in inlet valve there is on and off button, and in outlet valve there is on and off button too. So this is the gauge for water volume, so it will be seen in the CLCD. So now we will move to remote tank and we will connect it. So when the tank is full, so when we connect it, it will start filling. We will reset the PICSim Lab first, then only it will start working. So yes, as you can see, it is reset and it is started filling. So yes, as you can see, when the tank is full, the inlet valve will automatically turn off. So here we will wait till the tank is full. So it will show the temperature and the volume over the CLCD, and also the same will be shown in the Blynk IOT app. So the tank is full, the inlet valve will automatically turn off and the notification will come here that the tank is full. So the notification is shown here that the water volume is full. So as you can see, we have turn on the outlet valve. When we turn off on the outlet valve, the tank starts emptying, but if its value goes below 2000, as you can see now, it's below 2000, automatically the inlet valve will turn on. We will get the notification that the water is less than 2000 in volume and the inlet valve is turning on. So as you can see, inlet valve is turned on and it is started filling again, and the temperature and the volume can be seen on CLCD as well as on Blynk IOT application. So it is full again. Now coming to the second automation, we have done the control of garden light using LDR sensor. So I will show you. So this is the LDR sensor. When it is here we can vary the sunlight. When we have more sunlight, the LED turns off, but when we increase, like when the sunlight is more, then the LDR is sensing the sunlight and the LED will start blinking, as you can see in the left hand side. As we are varying, the LED is varying too. So this is the part of garden light. As you can see the temperature sensor, we have the same temperature on the sensor and it is visible on the heater too. Like you can see the temperature is same on the CLCD, and in the Blynk IOT app we will see the same temperature. That here you can see 27.34 in the temperature sensor 2, Blynk IOT app 2 and CLCD 2. So if we so here I have created two tabs, that is tab 1. Tab 1 has heater and cooler. So if we are turning on the heater button, we can see the temperature rises. As you can see, the temperature went on decreasing when cooler button is turned on. So here we can sense the temperature too. This is the whole working of our project. thank you so much for giving us the opportunity